High channels are the big new thing in immersive mixing, but setting them up isn't quite as straightforward as adding regular surround channels. In this video, we'll cover everything you need to know about your room, what equipment you'll need, and how to mount and calibrate height speakers. This video is sponsored by Sonarworks. Reference has been the premier choice for stereo calibration for years, and with newly added support for multi-channel audio, you can use SoundID Reference for immersive and Atmos setups as well. We'll talk more about calibration later in the video, but first, let's talk about your mix space. One of the most important considerations when getting into immersive mixing is making sure your mix space meets certain guidelines. If you want to mix in Atmos, Dolby lays out a fairly long list of guidelines they expect you to meet. However, many distributors don't require you to meet every one of those criteria. You can find those guidelines through Dolby's professional support pages, which I'll link below. But I wanted to highlight three main considerations I think you should meet regardless of whether they are strictly required of you. The first is ceiling height. It's generally recommended to have a ceiling height of at least 11 feet for layouts with height channels. Unfortunately, that can be hard to achieve, especially in a home studio, but I highly recommend ceilings higher than 8 feet, which is the standard for most modern residential construction. Fortunately, I have an older home which has 9-foot ceilings. This is helpful because it gives you more room to place your monitors correctly. We'll come back to this later, but you don't want to use in-ceiling speakers that are typical of home theaters, which means you need room to mount your speakers and an appropriate distance behind them to ensure they have enough room if they're rear ported. The higher your ceilings, the easier that will be. Secondly, it's a good idea to ensure your room meets the minimum size requirements. Dolby recommends, with current guidelines, a room volume of at least 50 meters cubed. This will ensure you have plenty of room to lay everything out and get good performance. Dolby also has guidelines for room layout, but I won't get into those. If you want all the info, you can find Dolby's Home Entertainment Studio Technical Guidelines online. The last main consideration is acoustics. I have a few videos that go into a bit more detail on acoustics, but the main consideration for an immersive room is you want the reverberation time to fall within a certain range. That range depends on the size of your room, but generally you're looking at somewhere between 100 and 600 milliseconds of decay time, with larger rooms being slightly more reverberant. You also want to ensure that the decay time is fairly even across the frequency spectrum, with generally a slight bump in the low frequencies. This is important because while you can correct for frequency response with calibration, you can't use software to make the room less reverberant. I talked a lot about equipment in my video on 5.1 setups, including all you need to know about audio interfaces and control systems, but there's a few extra considerations for selecting height speakers. First, as I mentioned earlier, you don't want to use in-ceiling speakers that are common for home theaters. These speakers generally only have a single driver, they can't be aimed at your listening position, and just generally aren't designed for professional audio work. Instead, it's better to use proper monitoring speakers. Like regular surround channels, you typically want all channels to be the same range of speakers. Ideally, they would all be the exact same model, but if you want to save a bit of money, you can substitute a smaller, less powerful version of the same monitor for your surround channels. This is especially true for height channels. Smaller speakers are easier to mount above you, and studies have shown that low frequencies don't contribute to our perception of audio height. About 5 to 600 Hz is the lowest frequency range we can perceive coming from above us, even if you're an experienced professional. So if your height channels don't have as much bass, it's really not a big deal. Personally, most of the time when I'm mixing high elements, I filter everything below 600 Hz as it helps things sound more like they're above you, so response between 200 really doesn't matter to me. For that reason, I'm using the PreSonus Aris 3.5 monitors, as they're inexpensive, compact, and have an impressive amount of clarity and detail for their price range. The low end is pretty resonant, but again, I don't really care about that. I had the chance to demo them, and they match the signature of my Atom T5Vs fairly well out of the box, and of course with frequency calibration, any differences are mostly non-existent. I would have preferred to use a 3 or 4 inch version of the Atom T series, but sadly, that does not exist. Unfortunately, none of my speakers have first-party mounting options. Some higher-end brands like Genelec and QSC do, but for cheaper setups, you'll have to come up with your own solution. Before we get there, we need a support structure to mount our speakers to. There are many different approaches to this. One of the most commonly recommended is to build a truss system, which provides mounting points for your horizontal plane speakers as well. I'm not a fan of this for a couple reasons. First, it can be very expensive, and metal truss is generally overkill for how much studio monitors weigh. Secondly, truss is hollow, which means it will resonate at certain frequencies, changing the acoustics of the room. The Atmos mix room at my college had this issue. There are ways to dampen this, like filling the truss with sand, but it adds extra weight and cost to the system. Personally, I built a structure out of wooden 2x4s. They're solid, so no worries about resonance, and lumber is comparatively inexpensive. The main concern is ensuring that you attach the frame to your wall in such a way that it can safely support the weight of the lumber and your speakers. Because the monitors require specific positioning, you may not be able to rely on screwing directly into wall studs. In my case, I used shelf brackets to provide a bit of extra support. I also have the luxury of thicker walls than you'll find in a modern home. If you don't feel totally comfortable with this type of work, I definitely recommend consulting a professional. To mount the speakers to the support system, I used 2 pairs of monoprice speaker mounts. These are not the most durable things in the world, and I wouldn't recommend them for anything heavier than the Ares 3.5s. The main consideration is they need to be fully articulating so you can aim the speakers at your mix position. The main speaker and satellite speaker on a pair of Ares 3.5s are slightly different, and this meant I had to use different mounting positions on each speaker. I put my main speakers on my front beam and both satellites on my rear beam so that I could maintain appropriate positioning with the different mounting points. The main speakers have a metal back which unscrews. I drilled through this and used bolts to secure the mount. The satellite speakers have a wooden back, so I use standard screws with anchors. Whatever speakers you use, always make sure that your mounting mechanism isn't going to damage any interior components. Once the mount is attached, you'll need to make some measurements so you can offset your mounting points to compensate for the size of the speakers. I measured the depth, width, and height separation between the acoustic center of the speakers and the center of the mount, which we'll use in our calculations in a second. Ideally, our height speakers should form a square above us. That means a 90-degree spacing between them with a 45-degree offset from the center channel. If you can't achieve this precisely, somewhere between a 30 and 60-degree angle is acceptable. We also want the speakers to be 45 degrees above our listening position, but again, a range from 30 to 55 is acceptable. This is measured from the elevation angle of our screen channels, which ideally should be 0, but might not be if you have the screen channels moved up or down to avoid your displays. Like my video on setting up a 5-1 system, we can use a bit of trigonometry to calculate the dimensions we need. The difference is that now we're dealing with a 3D space rather than just 2D, which slightly complicates things. Rather than using a single triangle to represent the speaker's position, we now need 2. A neat quirk of geometry makes this a bit easier. Because we're dealing with 45-degree angles, that means we're dealing with isosceles triangles. When you have 2 isosceles triangles where the hypotenuse of one triangle is the base leg of a larger triangle, the base legs of the smaller triangle will be half the hypotenuse of the larger triangle. In more simple terms, the horizontal dimensions will be half the distance our speaker needs to be from us. For example, in my setup, I have my speakers 4 feet from my listening position. For my front left high speaker, it needs to be 2 feet forward and 2 feet to the left. A bit more trigonometry tells us the height element needs to be about 2 feet 10 inches. Remember that our measurement needs to be where the acoustic center of the speaker is, so to find our mounting point, we need to add in the offset we measured earlier. Based on this, we can determine where our frame needs to be and where our mount points need to be to attach to the frame. From there, it's just a matter of making it happen. Once everything is in place, we can proceed with calibration. If you want to calibrate things manually, I recommend checking out my previous video on 5.1 calibration. High channels are calibrated the same way as the rest of your surround channels. If you want better results than you can achieve with manual calibration, that's where software like Sonarworks SoundID reference comes in. By taking sophisticated measurements, SoundID allows you to compensate for frequency response, delays, and volume in a way that's more precise than you can achieve manually. As I mentioned at the start of the video, SoundID now supports multi-channel setups up to 9.1.6. I've got a 514 setup, so we'll select that option. The whole calibration process should take you under an hour. All you'll need is an SPL meter with C weighting and slow measurement, as well as a calibration microphone. Having a Sonarworks mic allows for even more precise calibration thanks to factory calibration profiles, but you can use another brand if you already have one lying around. I also recommend grabbing some ear protection as the sound levels can get a bit loud at times. We'll start by manually calibrating the sound level. This is done with an SPL meter set to slow C-weighted measurement and placed at your listening position. Target levels depend on what type of work you're doing and personal preference, but generally you want to be able to reach between 79 and 85 dB on each channel. We only need to calibrate the center channel. The rest of our channels can be set to roughly the same volume as the center channel without careful measurement. SoundID will help us match them perfectly later on. You'll want to play pink noise through the center channel with a level of -20 dB RMS. Then adjust the volume of the speaker until it matches your target. Now we can move to the SoundID reference measure software. The software does a great job of walking you through the whole process, but I'll add that you want a fairly sturdy mic stand you feel comfortable moving around, and your XLR cable needs to be long enough to reach all of your speakers. The first step is to ensure your speakers are plugged into the right outputs and to make sure your measurement mic is working properly and has an appropriate gain setting. Next, you'll do measurements from your stereo monitors and your listening position to get the overall dimensions of your speaker layout and ensure your listening position is placed appropriately. Then you'll go on to volume matching, where you can more carefully match the rest of your speakers to your center channel, including the LFE channel. Last is the most time-consuming process. SoundID uses echolocation to guide you to place the mic in 37 unique spots around your listening position, then does measurements in each spot. This allows for advanced time and frequency correction to give you the best results. Once you've finished, you can save your results. There's two ways to utilize your results: through the SoundID reference app or through the plugin. Either way, you can load your calibration result and select a reference target. Keep in mind that by default, the software adds a bit of safety headroom to prevent clipping caused by the calibration curve, so this will affect your calibrated level unless you disable it. If you use the app, it will take over as your audio driver, allowing you to play any audio from your system with your calibration. Unfortunately, at least right now, the app only supports stereo on Windows, so any multi-channel content outside your DAW won't be fully calibrated. The reference plugin goes on your main output bus of your DAW and can support whatever multi-channel setup you have, allowing you to mix with full confidence. Just make sure to disable it before you render your project. Anyway, that's it for this video. Hopefully this video told you everything you need to know about buying, setting up, and calibrating high channels. If so, hit that like button. If not, feel free to hit the dislike button. If you have any questions or comments, feel free to leave those down in the comment section down below. And as always, if you want to see more videos like this, including all the upcoming videos on multi-channel mixing, definitely hit that subscribe button.